help here. Fred Baker is our advisor, and Warren Kumari is our AD here. Next page, please. So you should already be familiar with the noteware. I would just like to remind everybody that we work as an individual and try to be nice to each other. If you have not signed into MeEco, please scan the QR code, and also use your mobile to get into the MeEco queue before you speak at the mic. So today we have 2 working group draft, 7 individual and 1 operational. So we have a fully packed agenda. From a draft perspective, it's healthy. The trend is going up. Since IETF 118, I think that the working group made some good progress. First, more and more people know of the IPv6 mostly solution and are deploying it. Not only Google, but also actually right here in IETF 119, also in RIPE 87, in supercomputing 2023. So this is good progress. Also, since the last IETF, Nick became a co-chair, and he's doing a great job in bringing more enterprise to the working group. So this is great, but we still need more participation and active participation from enterprise, from carrier, and from academia. If anybody is writing your draft for the first time, because we saw some such comment in the mailing list, and you feel a little bit nervous, you can, for example, email Nick or me, or ask for help in the mailing list, and we can find somebody to work on the first draft with you to make the a little bit easier. And also, we move the DHCP-PD per device draft to IETF last call. This is a useful solution for a number of problems, such as address accountability, for example. So this is another important progress. And also, there are 3 drafts moved to working group last call or past working group last call. So this is part of under the guidance of Warren, we are moving faster the progress of draft in the working group. Moving forward, we want people to continue to contribute to Brian Carpenter's online book. This is really the central location of IPv6 wisdom. For example, after 118, we have a very long discussion in the mailing list on option 108 issues. A lot of valuable opinion was expressed, and Brian have already added some of the, for example, some guidance for IPv6 mostly deployment into the book. So this is very good, and again, we want more people to contribute to it. Because people started to deploy IPv6 mostly, it actually exposed many issues that dual stack masked. So now when people deploy it, I think that they need to know ahead of time what issues they may expose. And also, what can be the workaround. Jane is writing such a draft. I think that it's very useful, and we will try to expedite this draft. And we also call for other people to contribute to it. There's a request from mailing list to revive Tim Charles' address accountability draft. We can look into that. We also want to raise awareness of these 2 solutions. Again, one is this DHCP-PD per device draft. Also, in the DHC group, there's this address notification from Tim Winters. They solve some problems. I think that they address some of the, kind of like frequent complaints. So we want people to know. Other than this, we also hope people can continue to measure IPv6 packet loss rate, find out the root cause, and try to address them. We also got requests from people to start measuring the number of IoTs on IPv6. We have been measuring the people, for a long time, but I think that the methodology we use for people may not be able to be used for IoT. So they need some new methodology to measure. And this may be very good research topic for graduate students. So this is the working group status. How are we doing on time?
Kind of okay. Do we have a scribe?
A
scribe.
We have a note taker.
A note taker. Perfect. Thank you.
Well, if not, let's move on to the first presentation.
Thank you. Hello, everyone. This is Chongfeng Xie of China Telecom. Thank you for giving me this opportunity to introduce the latest update of the multi-domain and framework of multi-domain IPv6 only underlay network and IPv4 as service. With the rapid deployment of IPv6 only has been an important topic. Take my country China as example. The traffic volume of IPv6 network in mobile network has surpassed that of IPv4. So now IPv6 traffic is a mainstream. So we need to consider how to migrate to IPv6 only. Next.
You have it.
Doesn't work.
I think that your cursor needs to be
okay.
on the.
Okay. So this document specifies requirements and propose a framework for deploying IPv6 only as underlay multi-domain networks, and its purpose to provide end-to-end IPv4 service delivery over multi-domains and only underlay networks in a scalable way. We need to consider how to maintain the service continuity when IPv4 is closing as the core of the network. So this draft was adopted after IETF 115 in January 2023, and the current version is 4. This is about the revisions in the latest version. The term a multi-domain IPv6 only network is changed to its single form. We think it is more suitable. And the reference section has been revised. One reference item has been changed from the draft to its RFC, and another one is moved from the normative reference to informative reference, and the white item is removed. And we also made several editorial changes. And based on the comments of Jeff, the co-chair of IDR, we also made the revisions to the section of IPv6 mapping prefix allocation by adding additional illustration for network-specific prefix. This should be considered for the deployment. So we have received lots of comments and suggestions from lots of people of V6OPS, and we express our thanks. So we think that document is stable, and so we apply for last call in V6 working groups, and we also hope to receive more comments and suggestions. Yeah, next step, we think that's all. Thank you. Any questions? No question.
No question. Then maybe we move on to.
So the second presentation is an individual document. It's the first time to present. It's about IPv6. This draft illustrates how to leverage the advantage of IPv6 in promoting the Ethernet virtual networks, which use IPv6 as an underlay. So IPv6, a layer 2 network model built on top of IPv6 underlay to provide connectivity between dispersed customer sites. And with this framework, each network is seamlessly mapped to IPv6 underlay. with encapsulation, it used to carry the Ethernet data from individual hosts to others. And the purpose of draft is to improve layer 2 forward efficiency, guarantee security, and provide address-based ECMP by the capability of IPv6. And this draft was firstly proposed in October last year to 6-man working group, then moved to V6OPS in November 2023. So Even6 refers to the Ethernet virtual network over IPv6. Its scenario includes campus network, enterprise interconnection, branch interconnections, data center networks, and SD-WAN, etc. And take the data center network example. It should meet the requirements of isolation of virtual networks of different tenants. It also needs to support the VM, virtual machine migration across sites. And with these mechanisms, the Ethernet frame is directly copied into the payload of IPv6 network. And the state and mapping is used to generate IPv6 address from the MAC address, Ethernet identifier, virtual network identifier, and the set prefix. So the topology includes point-to-point, multi-point to multi-point, and point-to-multi-point, etc. So this is a framework of this architecture of this Even6. Even6 implemented by introducing e-adapt module in the PE devices, and so which is not implemented the core of the IPv6 network. With this e-adapt module that Ethernet frame to be transmitted is encapsulated into IPv6 packet and sent to the IPv6 network. So the packet will reach to the egress PE, and it will remove the IPv6 header and restore the original Ethernet frame. So this is very straightforward. As a common infrastructure, that IPv6 network need to support multiple instances of Even6. So here we introduce the identifier that is called V, that is 32 bits virtual Ethernet identifier to distinguish different instances of Even6. So 32 bits can identify about 4.3 billion instances. So it's a big number. And for each instance of Even6, a set prefix is introduced to identify each site, because each site is located in different locations. So different sites have different set prefix. There's no specific requirement to the type of set prefix, as long as it belongs to global unicast addresses. And the set prefix can be allocated from the address space, IPv6 address space of operators. So there's also a MAC VF, which is similar to that of EVPN. This is a table to store all the information of all the hosts, such as MAC address and V identifier and the set prefix, set prefix that it resides. So at the data layer, that the Ethernet frame is directly copied to the IPv6 payload by the e-adapt modules of ingress PE, and the field of that header is in IPv6 header is set to 143, and to indicate that the payload as Ethernet frame. This is about address generation by mapping, and series mapping is used to generate IPv6 addresses from the MAC address and the virtual network identifier and the set prefix. So there are 3 inputs right now. The first input is a set prefix. The source set prefix, the source site can be directly copied to the IPv6 source address, and the set prefix of the destination site can be copied into the IPv6 destination address. And the second input is the V identifier. It is split into 2 parts, VS1 and VS2. VS1 is a 16 bits, 16 bits, 16 bits, which is copied to moved to the IPv6 source address, and VS2 is copied into the IPv6 destination addresses. And the third input is the MAC address. The source MAC address is copied into the IPv6 interface unfair part of the IPv6 source address, and the destination MAC address is copied into the interface unfair of the destination addresses. So from here, we can see that whether the MAC address is source or is a source or destination, it has one corresponding IPv6 addresses. So the network can easily identify each host based on IPv6 address. As mentioned earlier, that MAC-VF store the information of all the hosts. So it provides the data foundation for the encapsulation of the Ethernet frame into packets. So the data in MAC-VF should be available before encapsulation of Ethernet frame. So the sites all need to exchange the mapping of MAC address and set prefix in advance. This exchange process can be implemented at existing control layers, such as EVPN, etc. However, this has been out of scope of this document. So this is about the process of packet decapsulation and the Ethernet frame storage at the egress PE. Suppose PE1 is an egress PE. When it receives as if this is packet, it will check that whether the destination address match one of its set prefix. If yes, it will extract the VS1 and the VS2 from the IPv6 source and destination address, and then merge them into V and unfair, and then check whether the V value extracted from the packet match one of the corresponding set prefix. If yes, it will check whether the that header is 143. If yes, it will then the PE1 will decapsulate the packets and restore the Ethernet frame from the packet and send it to the end host based on the destination MAC address. Otherwise, it will be considered as an abnormal situation, and the packet will be discarded or forwarded to other nodes. So this gives a small summary of the characteristic of Event 6. As we all know, there have been several methods of Ethernet virtual network over IP underlay or layer 3 underlay. Each of them treat IPv4 and IPv6 as same as a functionally equivalent technologies, underlay technologies. But IPv6 has a number of capabilities over which is not available in IPv4. So we think that this capability can be used to enhance Ethernet virtual network over IPv6 underlay. So based on this, Event 6 has the following characteristics. The first one is that it will improve the forward efficiency because layer 2 frame is directly copied into IPv6 packet without extra encapsulation, and encapsulation and processing cost is reduced. The second one is that it has delivery flexibility, since that Event 6 can be provisioned at the edge of a network, and as long as the PE device is connected to the IPv6 internet, so there is no constraint from the underlying network. The third one is that it is very suitable for its working.
Sorry, Chongfeng, you may want to accelerate a little bit and
Okay,
save a little bit time for question.
So it will work for multi-environment networks, and that's why it's security, because then there's no static prefix tunnel bundle address, and that's why that will be helpful for traffic load balancing. So next, we're working on the system implementation, and we will do the field trial soon, and we're looking forward to receive comments and suggestions. And we also ask for the working adoption of this draft. Thank you.
Tommy Jensen. Tommy Jensen.
Okay.
Can you hear me?
Yeah.
Tommy Jensen. You might want to talk to the authors of the Connect Ethernet draft that was presented to the MASC working group. Your technical approaches are very different and probably have distinct goals, but at the same time, you quote the same scenarios, and you might benefit from swapping notes.
Okay, I will check with related drafts or documents. Okay.
So Eric Vink is an individual contributor. How is the multicast traffic handled in this case? the multicast at layer
Yeah,
2.
actually, this can support the multicast actually has been not covered by this draft. We will do multicast situation in next version. Consider this. You mean that? But multicast, right?
Multicast, yeah.
Yeah, multicast. We'll deal with multicast in the next version.
Okay.
Mm-hmm.
Eric Klein. I saw you mentioned 7432 in your document, and of course, like there are SRv6 and BGP best-based solutions for doing the same thing. Is the principal advantage just the lack of additional encapsulation overhead?
Yes, there's no extra encapsulation without any, for example, VXLAN encapsulation.
But you're still deferring all of the control plane mechanics, the MAC learning, and everything else to some other mechanism, possibly
Yeah,
the same.
I think that as a control layer, maybe there's some enhancement to the existing control protocol, for example, EVPN, something
Okay.
like that in a base working group.
And if you go back one slide, I think, no, just slide 9, the secure constraint. I'm wondering what your plan is to defend traffic injection? Because it seems like if I could guess the pref6 and the VEID of your network, I can just send packets directly to MAC addresses inside somebody else's network.
Currently, all the MAC address and virtual network identifier is put into the IPv6 addresses. Yeah.
Right. So
it's sent to the public network.
Especially between ISPs, anybody can inject traffic straight onto one of your VLANs.
Oh, we would deal with problem in the security consideration to how to protect the securities. We will do the networking next time.
Yeah.
Okay.
And is VEI the same as VSI, virtual segment identifier?
Actually, VEI is much longer because it's 32 bits, but
is it logically the same concept? It's the Ethernet attachment circuit?
Yeah, it's the same. I think it's the same type of identifier, but it's much longer because I think this is more suitable for large-scale networks.
Thank you.
Thank you.
Hi, Bob Hinden.
Hi.
This is really for the chairs. I don't understand why this is being presented in V6OPS. It's an operations working group. This seems like a new protocol.
Currently, we haven't considered as a standard track because we want to consider as a practice.
Again, I was asking the chairs.
Okay.
Well, I think that we can look into if it's more suitable for 6-man, we can move it to 6-man.
Well, I'm not proposing you go to 6-man, but I think there are lots of places in the IETF that deal with things like this, and it's not in either of those working groups.
Okay. So let's move on.
Thank you.
Hi, everybody. Tim Winters. I'm here today to talk about V6 and home gateways. So there's 2 presentations I'm doing. The first one is a working group document. This was previously, I think I've talked about it the last 2 IETFs. This is the main goal of ISPs today. Do a great job of getting out prefixes larger than 64. We did it. They're not just giving out 64s. It's going really great. The problem is we don't know how to use them. So 64 gets to the ISP edge router, and then it never gives out any more other than the ones that are sitting on its interfaces. Occasionally, they'll break them out, one to a guest network, one to the primary network. But for the most part, we've not seen a whole lot of gateways do prefix delegation on the LAN side. So we want to fix that. So the changes we've made since the last presentation. So last time I presented this, there was a little bit of an uproar about flat and hierarchical both being defined in this document. So what I did for this since then is I've removed both of the deep definitions of both of those. I point to them saying these are both options that you could do to delegate the prefixes in the home, choose your path. I reference the hierarchical comes from the cable lab specification, the eRouter spec. is where that's actually documented. And then flat, I basically document here in the, it's pretty straightforward that you give out prefixes of /64 everywhere to everybody. What we did now, so we reduced all of that text, and what it says now is it should be a default of 64. Obviously, if an operator wants to do something different, they can go nuts. But the default should be 64. So that gets us into cases where users don't know what they're doing and plug it in. It shouldn't damage the network. Okay, so after all of those changes, it seems people were okay with all of that. It got adopted in working group. I'm not sure there's any other changes. It took us a while to get this document adopted. The only other thing I did want to note about this presentation, we don't fully specify what internal routers, and what I mean by an internal router here is it's not a snack router, but it's not an edge router. The ones that sit in between those intermediate routers, we want to tell them what to do with prefixes. It's a pretty big hill. I don't know if we want to run up it. I had text in the original version of this about turning them into DHCP relays, and there didn't seem to be a whole lot of interest in doing that. So I've simplified it. I guess that's the only thing I'm looking for. And then working group last call, we can wrap this up. It's pretty straightforward. I think it's 6 different requirements in that draft. All right, I'm hearing nothing. I think this is ready for working group last call, Cherish. Okay, as he queues up, my next one is way more fun. This one is so to give everyone a little bit of history, the original document was 6024, which was the first V6 for CE customer edge routers, and then 7084 came out, and then we've gone, it's been, I think 10 years. I was kind of shocked by how long it had been for this one. Maybe not 10 years. That might have been node requirements. Anyway, it had been a while. We haven't updated this. So we think it's time to update it. There's a couple of basic things I'm going to talk about in this, but this is the update. So 7084 biz. Okay, so one of the primary things we wanted to do is the basic RFC updates. We were still getting CPEs who were complaining about, they were supporting 2460, not 8200. There were some really dumb things going on there. And they would point to 7084 and say, hey, 7084 says 2460. So we fixed all of those. So we take all of the basic RFC updates. So for those not in the know, that's 8200 is base V6, 8415 is DHCP V6 update, and 8504 is node requirements. Great. We removed the transition text. This was kind of a weird spot. When 7084 came out, we hadn't written a bunch of the transition technologies that exist today. We wrote a bunch more since then. Classically, what we did is all that text has been removed. We took it all out. There's a separate document that came out of this group, 85, 85, and 93. 13 that cover transition mechanisms, they talk about all the merits of choosing your path and choose your own adventure and however you want to do it as an operator. We removed all of that text. The main one got a little scary here for me was I've had some CPEs come to me saying because they read 7084, they had to implement 6RD with no interest in their operators actually doing it. So that's the kind of stuff we don't want to have happen. So we took all that text out. Another requirement we added in the original document, it was a should for ingress filtering. We think this should be a must. This is anti-spoofing. We want to stop malware from getting extra ways to get out in the world. This is an easy fix that would prevent a lot of malware situations. In particular, the scary ones where something's hijacking a bunch of IoT devices and doing bad things by generating spoofed addresses. All of those is easy fix. We should make this a must. There's no reason we shouldn't do that. 9096 we added, so that was an update to 7084. This has to do with, I'm trying to remember which one this is. This is renumbering, I think. This is stateful renumbering. So we added that in. That's just part of the regular biz update. We took all the updates in there. So we put those recs in there. The other one that started this actually was, there was a paper out there saying EUI64 on the WAN interfaces meant you could track people. It's not a great situation. So we say, hey, don't do that. Don't use EUI64 addresses on your WAN interfaces. It's a bad idea. So all that's in there. Great. One thing I did for people who, or we did as authors, the original 00 version is actually the same as 7084. So you can watch all of the changes throughout it. The first version was just an update to the latest tools, no formatting, formatting changes only. So then you can see a progress from 01 and 02 about all of these changes. So those are the changes we've made. I think those are the easy ones. The hard ones come next. All right, so this document has a strange history in that it's an informational document. I think it should be BCP, but we can talk about that. I think that's something in the past people have mentioned. Right now, it's still listed as informational. I didn't make that change. I don't know if people have opinions on that. And then I have a list of, this is the wish list that people have sent me. PCP, NTP on the LAN. One of my fellow co-authors said every box should have this, and I was kind of surprised. I don't normally see it in my lab. I don't see a lot of people giving out NTP and running it on the LAN that way, locally at least. So I was kind of surprised. Another one I'd like to hear some discussion on is IPv6 only preferred option. What we want to say, if we want to say anything about it, anything there. Gratuitous neighbor discovery. Are there other things? And then I have one more slide, but I'll take questions on these slides up here. I have one more slide about drafts that exist that I might want to include. I see some people have gotten in line.
So Eric is an individual contributor, obviously, here. When you say ingress filtering for anti-spoofing, I think that's cool, but do you have the provision that it can be disabled in the case of multi-homing?
So right now we do not have that text. The original one just said should and how to turn it on. I think we could add that text. I think that's that's a good thought. Yeah, it's a good thought. I agree. You can add that.
Jelinkova, regarding V6 only preferred option, I'm curious, so ideally you would need to combine it with pref64. And you only you need to enable this if you can do not 6.4, right? Either on CPE or somewhere upstream. So I think it's a great idea, but we need to be careful with how you enable it and what the trigger is, unless it's just a manual configuration for a user, for geeks at this stage and for operators later. But
yeah, I don't think we try to avoid the latter. So I think if we wanted to do this, I think we want to do it with operators in mind. So then yes, the answer would be you'd probably have to do 6.4.
Okay, so you basically expect the operator at some point of time start providing PLAT, and then you can enable IPv6 only preferred and send traffic natively. But then please don't do it without pref64. Because otherwise you would have to give them DNS 6.4 and it will break a lot of things, right? So
agreed.
Probably you want to add 87, 81 together with this.
Yep, agreed.
Dave?
Yeah, so as the past chair of the Port Control Protocol Working Group, just wanted to ask, is there a reason to not include it? I heard you say that these are the things you actually got requests for. I'd say offhand, I would say it's a good thing to include, and the debate should be whether it's a may, a should, or a must, right? So,
yeah, my instinct on this one would be should. I think a must would probably be too far, but I think should's about right because we do get this. I will say people are getting really creative in this space, and I think it would be helpful for people to know that this exists and can solve a lot of their problems. Definitely in the CPE space, it's not the first thing that people go and grab for solving some of these problems. So yeah, Dave, I think that's a good point. My instinct is to make it a should. The original one, I think, the original 7084 I text about, obviously UPnP and some other things that where I'll be taking out and just saying, hey, do PCP. It's the way.
Yeah, I was going to say the same thing. I agree with the should.
Okay, great.
Eric Klein, responsible AD for NTP. What is it you wanted to say about, or what did people ask me for NTP?
So Jordy, one of my co-authors, thinks that we should require that. The original version of 7084 says that NTP on the LAN, so this is handing out all the options and doing all of that, is out of scope, right? And he says, well, every CPE has that built in. from my perspective, I think we're talking two slightly different things here, right? I think it's one thing for it to be giving out an option with an NTP server. It's entirely different. I don't see a whole lot of home gateways come with NTP options giving out an NTP server, right? Most clients get it from someplace else. So I would envision leaving it that way instead of having home gateways handing out NTP servers.
I actually think it's both those things. I think they do seem to have the capability and to hand it out, but that like nobody uses it. They all have it pre-configured as part of their operating system by other mechanisms.
Yes, that is my right. I should put it that way. I'm not sure we need this because I think this has been solved in other ways. It would be my
right. That's not to say that it would have no value. You might ping NTP mailing list and ask them if for V5 if they'd have any preference.
Okay.
But I suspect, I mean,
it's a good thought.
Saying nothing or saying may is fine.
Yeah, may might be the way around this as well.
Must not would be a bit harsh, I think.
Okay. All right, thanks.
So Warren, Kamari, Google. I mean, I'm suspecting if you ask the NTP group, should we include NTP? They'll be like, yeah, shockingly. But like, I think that we should, for all of this, try and keep it to sort of the actual minimum amount of required stuff. Like,
yeah.
We run the risk of throwing everything into it and then people not being willing to implement any of it because it's a huge lift. So like the very minimum set of things that everybody agrees is, sort of required. Hand wave, hand wave.
Okay. My instinct here is just kind of remove the text that was there originally as well, because I don't think it quite applies anymore, but I think we can be careful about not saying you have to have this option in every DHCP message.
David Lamparter, to throw more onto this fire. There's two very different ways that this can be interpreted. The one is to actually just relay the MTP information that the router got from upstream, which sounds perfectly fine. But the other is to run NTP directly on the router, which is a horrible idea in my opinion. So it needs to be clarified which of the two this is actually referring to.
Yeah, I think if we say anything, we should be very clear about that. I agree. That's one of my fears actually with this whole thing.
Yeah, hello, Carsten here. So we work a lot of IoT networks, which are also offline. And seeing this discussion, I see that this is not reflected. And so if we have such a requirement, having NTP as a base function of a router, that means we need infrastructure, even in networks where we don't have an online router right now, and also in other situations. And so I would discourage to bring things like this into a router.
Okay. Yeah, one thing to remember, these routers in particular, they have an upstream ISP. So the offline mode doesn't really apply to these types of routers, but a point taken. The last thing I just want to mention here, these are all drafts that exist, that hang out, that might impact 7084. I think we should watch them carefully and discuss them. They're obviously going to mess with some things. Yeah, go ahead, Jen.
Yeah, Jen Linkova. So yeah, we will be discussing 3 of them.
Yeah.
Right. So yeah, I hope we can reduce the number of the drafts on your list.
Yeah, that would be good. I'd be a fan of that.
I can promise reducing amount of text in total, but the number of drafts might be like, yeah. So,
right. Obviously, in this case, we're not going to repeat the same things these documents talk about, but what we are going to say is, yeah, a CPE should do these things, right? If we want them to do, obviously the PD on the LAN, right? I presented on why that's so great and we should do it. So do that one. But the other 4, I think, are in different states, and we should talk about when they be available and how we want to deal with that. This is kind of one of those things with profiling / requirements, is choosing the moment that we put it to pen down. So these are the 4. If you have any others, please send them to the list. We'd be happy to discuss them, look at them. In particular, if there's any operators out there who have, I've run this by a couple of them, but any operators out there who really care about this stuff, please take a look. I think that's it. Yeah.
Okay.
Gave you a whole minute.
Let's move on. I think Paulo.
So good morning, Paul Volpato. I'm presenting the status of our draft on multiple site connectivity for business sites on behalf of the authors you see listed here. So just to give you a quick introduction about our draft. We have presented our draft in the past few meetings, probably with the exception of the last one. We took a sort of a break to, let's say, reshuffle the test and maybe change something that we had to fix after some comments we received on the list. Just to recap, so the draft is about to present the solutions currently available, so something that we can find in live networks, to support multi-homing connectivity based on IPv6. And the idea is to discuss the strengths and the weaknesses. Now, let me pause for a second here because I need to place a forward statement. The authors are not supporting or endorsing any of the solutions that we are addressing in our draft. That's important because we want to reinforce the message that our preference goes for, let's say, the native solutions that provide IPv6 end-to-end connectivity without any kind of translation. That's for our preference, yet in the field we find many more options. So the idea is to take them and discuss in our draft. The reason for doing that is that you find a few references. Probably the most important is listed at the bottom of the slide. So it's RFC 4984, which discusses the evolution of the use of PI addressing for providing multi-homing connectivity based on IPv6 for business sites. There are some indications. It's not important here to discuss whether that's correct or not, whether the projection is right, but in any case, that's a reference. So said that the solutions are clearly based on IPv6, and we know that native solutions have drawbacks. So the idea is to discuss them. The solutions are listed there. So we are considering both native solutions and what we define as stopgap, let's say something that could be used on a temporary basis. They're not expected to stay there for a long time, but yet they are there today because they are used in some implementations. Now, the characteristics that we have considered in the analysis come from RFC 3582. So basically, we have taken some requirements for IPv6 multi-homing connectivity. They are listed on the right of the slide. Let me skip all the list, but basically you see that ideally the solutions, the technologies employed should support clearly end-to-end connectivity, provide site resilience through multiple carriers, and even one of the CPE or the CE gets a failure, goes down, yet the internal connectivity should be granted and supported, and so on. You can clearly read the draft and see all the discussion about that. You see there is space for more requirements. So I just anticipate a question that I will repeat in a minute. We are open to any contributions that you see as important and valuable for discussing the draft. Then we took the requirements against some scenarios. You see one represented there just for the sake of providing an example. That's the case of use of provider aggregatable solutions. So you see there are prefixes or addresses that are sent to the host from multiple carriers. They are different clearly because we have two CPEs connected in some way to different providers. And those providers may have, for example, dedicated services such as walled garden. Then we have active configuration for the two CPEs and so on. So all the characteristics clearly are listed in the draft, and you can dig into details there. So what we have done from the past version, so we are currently at version 0.3. Basically, we took some time to review the problem statement, the history, especially for the PA case. We wanted to update the text also to consider the draft on DHCP PD per device, clearly. We have also inserted some clarification. And basically, there is something we want, again, to stress that we are not supporting the solutions based on translation technologies, but yet they are there. So we have to consider them. And we have also reviewed the final table where there is the comparison of the different technologies, where we clearly highlighted, let's say, the native solutions from a technology standpoint provide more advantages than those based, for example, on MPTV6 or NAT66. And we also add an appendix, and I'm going to introduce that in the next slides. The idea was to try to see what is really used in the field. The survey, I can say, got, if I remember correctly, 22 answers, unique answers. So probably from a statistical standpoint, it's not yet so, I would say, meaningful, yet it's the first indication. What is used in the field? Well, you see, for example, question 1, how many CPEs are used? The majority says 2 CPEs to have, let's say, the support of at least connectivity to 2 different carriers. Question number 2, how they are configured in terms of uplinks. You see more or less the situation is a kind of split. There is 1 link per carrier. It's around 50%, and there are cases where at least 2 or even more. Question number 3, what's the typical configuration? The majority of cases active. And just to go a bit fast and leave room for some questions, is it used VRRP or any other dynamic exchange of information? You see more or less, again, the split is almost even. And then we asked also what is really used, and you see the let's say the list of the solutions adopted. So we have PI addressing, and if you sum up PI and PA, I would say that's the majority of the cases. Clearly, we have only 12 unique responses. So again, probably it's not so statistically meaningful. So there is the opportunity to get more information. But in any case, you see that there are implementations using either ULA or GOA with some sort of translation. So that I'm moving to the end of the presentation. So we are open to any proposals to, let's say, add more options, more requirements. And also we got some good comments on the list about the survey, but also one comment saying it was a bit confused. So if there is any idea we can collect to improve it and maybe to expand the footprint, we are very happy to do that. The draft received quite a good bunch of comments. So we are just asking the audience if maybe it's time, if it is ready, if you consider it's good for adoption or anything stands against that. Thanks.
Hi, I'm Bob Hinden. So can you go back to the last survey slide?
Yes.
Yeah, so it seems to me that given you got 12 responses showing 6 different choices, I don't think there's, I think for this survey to be useful, you need a way more people to respond. I don't think you can really draw any real conclusions on these different things given the amount of participants who in the survey. So I think at best is misleading. We know that the only real solution now is PI addressing, and yeah, I think you're just getting individual responses to the others.
Yes, maybe I was not clear enough. In that case, it's my fault for sure. I mentioned it's a very first indication. It's not an exhaustive answer, and definitely agree with you. So let's see what is used. It's just, first mark about that.
Jelinkova, I checked, I read the draft, but maybe I missed it. We kind of assume when we're talking about multi-homing that the device has 1 link, right? Because this device is strictly speaking multi-homed on V6 most of the time, right? It's connected to Wi-Fi, it's connected to mobile carrier, and users are mostly happy. So I think part of the problem is that we're trying to do a host multi-homed over single logical interface. So maybe that's a solution. I think solution actually been developed and called PVD, right? So as long as you can introduce logical links, logical interfaces on the devices, right? It might be a solution. But I do not see PVD being mentioned in your draft at all. Oh, a second comment quickly. I do not think it's clear about what kind of networks you are talking, because you're talking about CPEs and other things, right? For reasonably large networks, they don't have CPEs, right? They have like large networks infrastructure without CPEs. So I don't know if you want to limit the scope or you're talking about it like any network.
Very quickly, any comment is good, but for the scope is business sites. So I would say anything that could be considered as null office, home office, even medium sites. But if it is not clear, we can work on that for sure. And then you mentioned PDV. That was an old question. I think we already discussed that, but we can go back maybe to the list.
Tom.
Ciao, Paolo. Tom
Hello,
Hill
Tom.
from BT. I think in the way when you're collecting these results and the analysis that you're doing upon them, I've been quite troubled in recent months, years, of the excitement over MPT. I think there's it feels a little bit like a crutch. You know, everyone's so very used to using NAT and with IPv4, and they've suddenly discovered this MPT thing, and they go, oh wow, we can do the same thing. I'm not entirely sure we should be encouraging it so much. But I think when we're clarifying this, a very small tweak to actually not list MPT and NAT66 as different solutions, because they very much carry a lot of the same drawbacks and the same problems. I suspect it's kind of, you're splitting hairs a little bit. There's not a lot of difference there. The other thing I was going to point out was, and I wonder whether this will cause some fuss, but realistically, I understand the elegance of the Pi solution, but I do have mild concerns about the growth of the IPv6 table as well, and the lack of aggregatable prefixes. So that perhaps we should be considering that as well.
Okay, for the second one, open to discuss it, even offline. For the first one that you mentioned, well, actually MPT and NAT6s are a bit different. So the idea was to document them. Again, we are not supporting them. So we are not suggesting they should be used or deployed. At the moment, in some cases, they are.
If our intention is to profess best practice at some point here on how this should be handled, I think it would be foolish for us to lean too heavily on what the customers themselves have determined what they want. So if they sit there and go, oh, I've seen this thing and it looks like what I've already got, that's not necessarily the thing we should be listening to. Perhaps we should be telling them there's not actually much benefit in this, you probably shouldn't do it. But that's the only reason why I suggest perhaps bringing translation technologies back to one option.
So let me say again, we fully agree with you. So there is no discussion in that.
Well,
we can maybe tune the messages. So just say again, but I think we already coped with that in the past meetings. Let's reword the text we have there just to say, again, they are not for real use. We are not pushing for that. At the moment, in some cases, they are used. We suggest to, let's say,
it takes one LinkedIn post.
Okay,
for this
that's a good suggestion
to go viral. So anyway, thank you very much.
Thank you.
Okay, so in the interest of time, David and Lorenzo, please be concise, and Paulo, just listen. You know, no need to respond.
David Lamparter. This is a little bit of guessing, but it feels, especially like from the survey, that the people filling in the survey are confused regarding multi-homing with cooperating ISPs versus multi-homing with non-cooperating ISPs, and those are very different problems. And some of these answers just don't make sense. So I would like, if you proceed with more data gathering, make a clear distinction here if the uplinks are cooperating or not.
Lorenzo Coliti, I think I think both the NPT V6 and the NAT66 solutions are basically ignoring the impact on application developers and the costs that are pushed on them. And I think we need to say NPT V6, and one thing that doesn't work for with NPT V6, for example, is peer-to-peer video chat, right? So I think we shouldn't be eager to push this damage onto application developers and onto users. And with regard to the question about progressing the draft, I think the only thing that we should say here is that this is an unsolved problem, and we should be spending our time solving the problem instead of proposing a variety of half-baked solutions which have a bunch of big drawbacks. That's what anyway, that was the.
Very quick comment, very quick one. People might be using this, right? Are they sure that V6 is working in their setups? Because if they run dual stack, they don't really know.
Okay.
Okay, let's move on. Nalini, I think that you are the next.
Okay, thanks so much. So this is some work that we did at NITK Suretscom, and we will continue to enhance it. And Amog and Chinmay, who are who are final year undergraduates, have been working with us. And the impetus for doing this work is we would like for IPv6 extension headers to be used, and a lot of people were asking me, well, how do we start using them? How can we actually use them, and so on? So Amog.
Yeah, hello everybody. I'm Amog. So I'll be presenting implementing an extension header, a PDM, which is a destination options, using eBPF. Yeah, so extension headers have many uses. Routing efficiency, we can control source routing and specific paths using extension headers. We can see how we can route packets to different means using extension headers. There's also network diagnostics, the one that I have implemented, which was PDM, another extension header, destination options. There's also security enhancement from extension headers, mechanisms for encryption, encapsulating payloads using extension headers. And then this is not even including fragmentation, which is also another header, and hop by hops. So all of them offer a lot of flexibility to IPv6, which isn't already there. And while trying to implement an extension header, which is non-standard, or while trying to experiment with extension headers, we found there was no easy way to do so. And eBPF is something that we thought could be helpful here, and we used eBPF to implement the destination options header. So why did we choose eBPF against, we could use raw sockets, or we could implement in the kernel itself, compile it into the kernel. So the kernel development is quite time consuming, and we can't port it across different versions. So there's lesser maintenance with eBPF. Any small changes will not break it. It is more robust, different kernel versions, different operating systems, and there's also better portability. And the BPF verifier, which is something that tests the BPF programs before they're loaded into the kernel. They ensure that you don't see any undefined behaviors, you don't crash the kernel. And then there's also the accuracy of timestamp. This has something to do with PDM. So in PDM, we are collecting just wire arrival time, and that's more accurate in the eBPF hook points that we're using rather than when we get to the IP layer in the kernel. And also, why eBPF over raw sockets? We don't have to build an entire application that just adds this extension header. So we don't have to modify user space applications to do so. And then there's also, we don't have to craft the full packet. We just have to make space in the packet in the eBPF hook point that we're using. So it just reduces our work as well. Implementing PDM using TCBPF. So we used a specific subset of eBPF programs called TCBPF. They are in the traffic control hook point of the kernel, and PDM is defined in RFC 8250. So we used TC, which is can be attached on both ingress and egress. And another candidate for this could also have been XTP, but it currently does not have egress support. And we also use something called BPF helpers, which allow us to add room to the packet, or it allows us to write to the escape buffer of the packet. And it also allows us to make modifications to the packet, and then we store the 5-tuple state in eBPF maps, which is a shared data structure between both the ingress and the egress programs. We also sort of benchmark this against something that we implemented in the kernel. So we compiled PDM into the kernel, and then we saw if there was any performance drawbacks, if there was any sort of disadvantage, or how good this technology itself was. And we measured against CPU cycles, network throughput, and packet processing latency. The test setup was 2 VMs on the same physical host, and of 8 cores and 16 GB RAM each. And we simulated traffic through IPEF and then collected the measurements using perf. For CPU cycles, we individually measured both the eBPF egress and the ingress programs. We see that they're an order of magnitude higher than the PDM kernel program. We ran this for 5 minutes of simulated traffic and 30 times each, and this was the mean CPU cycles that was being used. Does this really translate to real world network bandwidth throughput reducing it? We'll see in network throughput, we don't see we do expect that without PDM, without either the kernel or the eBPF implementation, that we have a pretty high bandwidth. We get the highest possible bandwidth, and while adding PDM, we lose a bit of throughput, and this could be attributed to we're doing extra processing to add the extension header, and compared to the kernel implementation, eBPF, it performs slightly worse, but we would say it's not so bad that we can't want the use of eBPF. It's quite good. It's almost up there, and compared to the flexibility that it offers to all of adding extension headers without modifying the kernel, without going to the pain of swapping the kernel in wherever we need the applications. And then coming to packet processing latency, we used ftrace to get the mean execution time of the functions, and so we use a kernel function called devqxmit, which with eBPF egress and without eBPF. For the kernel implementation, we could directly measure for the function itself, but for eBPF, we were not able to do that in ftrace, so we would do it with eBPF programs attached and without. So to get the execution time of the eBPF program itself, we just subtract them, and we get 1.28 microseconds for the egress program. And for the kernel egress, which is for egress, we get 0.7 microseconds. So slightly worse than the eBPF, but still pretty good. And slightly better than the eBPF, but eBPF is still pretty good. And then we also have for eBPF ingress packet processing latency, which is 0.5 microseconds. Yes, any questions or any thoughts? This is about the presentation.
Any question, comments?
Just one comment from Eric. We talk about the newcomers reception because you were there. So big congratulations to present something on your first IETF meeting.
Yeah, thank you.
Well, if no further question, then let's move on.
Thomas Jensen.
Jane, maybe we let Thomas present first, and then you present your 2 drafts together.
Thomas first, and then to you.
Okay, maybe you present your 2 drafts first, then.
Let me present my first one, because there is a reason. Tommy's draft might be referring to what I'm gonna say.
We were trying to help.
No, thank you. You can close your eyes, Warren. I don't want to compete with my slides for audience attention. Anyway, so you're gonna see me quite a lot in the ping box this week, because as a result of my V6 mostly deployment, I have found a number of issues Some of them probably needs to be fixed here in those rooms at IETF. So this is one of the problems I discovered. I actually mentioned that during my presentation the last IETF about like V6 mostly deployment, but I think it would be nice to spend more time on these particular issues. So yeah, renumbering strikes back. There are many cases when renumbering in IPv6 breaks things, right? We've heard quite a lot from people who care about ISP deployments about CPEs and prefix delegation. When delegated prefix changes, CPEs might not propagate the change to the client, right? But also in like enterprise environment, we have other cases of renumbering. Slack prefix might change. For example, if you have proper intent-driven network, you change your intent, configuration is pushed, your like prefix is renumbered, or maybe it's just a manual config change. Also, in enterprise environment, it's quite possible that the host might be moving between links or between subnet. It depends how you look at this, right? Example is it might be Wi-Fi roaming, or it might be actually for wired network change. VLAN might change. Again, automation might reconfigure the VLAN on the switch port, or if you're using .1x, as a result of .1x authentication, the device might be moving between different VLANs. When radios provides a VLAN number, reauthentication event might lead to VLAN change. And actually, most of things I'm going to talk about actually applying to multi-homing, because multi-homing is very similar. You have multiple prefixes and you need to know which one to use. In case of renumbering, it's actually basically a corner case, right? You have two prefixes, one of them is not working. In multi-homing, you might have both prefixes working, but this is just, yeah, we have one you need to know which one is good prefix. So yeah, just a recap on subnet changes, right? It's what I observed in my network. .1 authentication moved place port to VLAN A. It gets prefix A, and later the client might move to another VLAN. Ideally, in the ideal world, the client needs to detect this, understand that .1x state changes from authenticated to non-authenticated or vice versa, and do something with IP stack. In reality, I do not know if any host operating system does the right thing here. All of them are just, I'm fine. And as far as I know, most like enterprise operators, if they using this, they put in some automation around this to deal with that. So again, it would cause an unpleasant effect of host having two prefixes, only one of them actually working. Interesting case I also discovered is actually Wi-Fi roaming case. Think about Wi-Fi infrastructure. Like we have the same SSID everywhere, right? And if you have two networks, two buildings close enough to each other, you might see the overlap in Wi-Fi coverage, and user is walking from one building to another. It roams between two APs, the same SSID. In many cases, if you have VRRP, you will have the same MAC address because it will be VRRP MAC-based, like VRRP virtual MAC, which is derived from VRRP ID. And why would I have different VRRP IDs in the same VLAN but in two different buildings? No reasons, right? Some implementations violates VRRP with 3 RFCs, which actually prohibits to derive virtual link local address from MAC address. But a lot of implementations do this. So basically, from host perspective, it moving between two APs. Default router is still the same. Link local address is the same because it's VRRP based because it's based on virtual MAC address, which also did not change because VRRP ID is the same. So client like, okay, looks like L2 roaming. I'm fine. I'll just keep my network configuration. And indeed, nothing works here. So favorite rule 5.5, which is supposed to help here, right? So what's going to happen if client has two prefixes, blue and pink? It needs pick up one after it selects the default gateway, right? So let's think about it. In previous case, right, we have the same MAC address and same link local address for all routers. What if each VLAN has its own link local address for a router. In this case, obviously the client has two prefixes but only one default router, because the second default router will be removed quite quickly from the default router table because of neighbor unreachability detection. The link local address becomes unreachable because that router is on another VLAN on another subnet. It does not exist. So if client implements rule 5.5, then client will be always picking up the correct source address. And fortunately, a lot of operating systems, especially used in enterprise environment, actually do this. So, as I say again, right? Yeah, solution. Everything depends on the fact, including actually, you know, this is great RFC about detecting network attachment, DNA, for IPv6. They explicitly say that that thing could only work in the assumption that your default router, link local address, and MAC address are different when we move between links. So why would router have the same link local all the time? First of all, we normally do not care about what link local address the router has, right? Because it's supposed to be specific to the link. It could be actually the same between different links. The scope is the link. So again, for VRRP, it's quite common to have the same link local everywhere for the same group ID. Administrators love to configure something they could remember, like FA80::1. And unfortunately, well, I know the team is trying to change this, but some routers might use UI64 or proper algorithm for generating stable addresses. In this case, if you have prefix change, but link is the same, right? Then your /64 change, but the link local address of the router does not change. So can we change this? I think we can. So what if link local address of the router, at least link local address the router sends arrays from, actually depends on the prefixes which are assigned to the interface. So basically your interface ID, because network prefix is link local FA80, should be actually a function of PIOs in array. So as if that set of PIOs changes, then link local would change. So basically, logically, it would look like now we have another router on the link. You've been using router A, now you have router B. It doesn't matter that it might be physically the same device. Link local address changes. How could it be done? This is V6OPS, right? Because you could actually do it today. I've rolled it out, and it was amazing. All those complaints about devices getting two addresses from two prefixes not working, all those complaints disappeared. Almost, that's why Tommy is presenting after me. But for native IPv6 traffic, it just works. I forced my routers to use VRRP virtual address, which is a function of prefix. Function is very simple. I'm using network prefix 64 bits as an interface ID. Because, yeah, we can come up with more complex logic, but why? I can guarantee that my /64 is globally unique. So if using this as an interface ID, it's also guaranteed to be globally unique. And because I have only one VRRP ID per /64, a VRRP virtual link local per /64, it just works. So you can configure it on the most router platforms today. And for CPE cases, which I think it would be very useful, we can use, I don't know, the standard algorithm defined for stable interface ID, where you can use your PIO as a prefix. So I know that in some cases it might be desirable to have stable link local. For example, if router is used as DNS server. So theoretically, a router might have multiple link locals. One is stable, which doesn't depend on the prefixes, and then per prefix sync. So recovery time, I'll skip it, but with default timers, it's like about 40 seconds to detect neighbor become unreachable. Plus, and here is a 6-man draft, so come tomorrow, we need to make sure routers propagate the information about prefix change quickly. And the last thing, I have 4 seconds. I presented it in 2016 in Berlin IETF for multi-homing case. in multi-prefix case, let's say you have global and you have ULA, and you do not want to disturb your ULA flows if your global prefix change, it's actually might be beneficial to send different arrays for PIOs. So array per PIO. So if only one of prefixes on the interface changes, only one router disappears and the second router stays disabled. This is a kind of gray area between 6man and V6OPS, because completely opposite thing was proposed in expired Slack Renum draft. They actually tried to bind everything in one array. But I think, and we discussed it like 8 years ago in context of multi-homing and PVD, it's actually might be very useful because it helps with multi-homing and remembering. And yes, I'd like to ask for adoption if people think it's a useful idea.
Okay. Tim Winters, QA Cafe. So a couple things in this one. I'm going to leave the 6man stuff for 6man. I have some thoughts for you. But one thing I want to say is, as a recovering guy who used to test a lot of enterprise routers, a lot of them make you configure their link local. They have no auto-generated link local addresses. And reading this draft, I do not think it's clear enough what you want them to do. Do you want them to statically set these differently? How are they going to deal when they're dynamically or setting prefixes? What are they going to do with their link local addresses? Because CPEs, this is a different problem. But for enterprise routers, this is not normal. What you're asking them to do.
Well, I recommend them, if they care about renumbering and mobility case, to use some algorithm for explicitly configuring link local address in a way that it's unique within the mobility domain, whatever mobility domain is.
Right, but the thing I'm pointing out is many of them do not auto-generate their link local address in any way.
Well, it's easy. They could configure them manually then, right? That's a.
If that's what you want to tell people to do, I don't think this is going to be successful if that's the game plan. If you want operators to figure out how they're going to set every link local address.
Okay, we'll continue this, I guess, offline for the sake of time. But yeah, thank you. I did not think about that. Yeah, I will.
So I think it's the point you want to address is totally understand. So we face this problem very often. But I wonder, would it be maybe simpler just to say, don't use link local address as a gateway, just use the ULA of a router as?
No, your neighbor discovery works on link local, right? Your router sends arrays from link local. That's what hosts install as default gateways.
Yes, so maybe very controversial here, but just this is a general problem we have. And if we have routing, we have somehow routable addresses there. Why don't use them for routing and not use
you want router to send addresses from the global address, arrays from global addresses.
Yeah, from unique local. So the router, then just we have a first phase. Of course, we make a neighborhood discovery, and also the router advertises itself. But when the router advertises itself, it can say, okay, I have this.
You would still need to deal with neighbor discovery then. You would not get your default router address immediately in array, which actually complicates things significantly.
Yeah.
And it's again a 6man discussion because you're talking about changing neighbor discovery. You're talking about changing 4861 right here. So yeah, I guess we can continue it in 6man or in the lobby. Yeah, like.
Okay, please take, yes.
Yeah.
David Lamparter. I think we should pick between having the one link local address and change it when the PIOs change versus having a link local address each for the PIOs. Personally, I strongly prefer the latter, but I do think that having the both in the draft is creating confusion, and we should just pick one and stick with that and try to get that into consensus.
Okay, sorry. Yeah, I need to change the wording in the draft. In general, I'm saying, okay, array is a function of PIO, and there is only one PIO. Yeah, so it's basically applies. Okay, yeah, I got your point. I will work on the wording.
Warren, you still want to?
Yeah, I mean, I guess so. I did leave the queue because it was closed. But I do think at some point, they're like, should we be instead like advertising the global? Should we reevaluate the whole link local idea it feels like there are a number of things in V6 which maybe we should evaluate the actual original design decisions on, right? Like Jeff did an interesting presentation on IPv6 fragmentation and how it's not necessarily working in the real world. At some point, we might want to actually look at this whole architecture and be like,
you might not have global address in general, right? You might have link local network.
Sure, I'm not saying like fix that specifically, but as a general thing, you know, it's been 20 something years. Should we look at the whole architecture and be like, are we actually doing what we wanted? It feels like a lot of like, we built it like this a long time back. If we just did IPv6 harder, it'll be fine.
6-man discussion again. I'm walking away from the mic.
Okay.
Tommy Jensen here to follow up on that fun and talk about CLAT recommendations. Why though? There's some subtle gotchas when turning on CLAT. We just talked about multi-homing, and we'll talk about how we tackled that in this draft and what we have remaining open, as well as not breaking upper layer protocols, because there are ways to do this with address selection that can do that. And then, of course, other RFCs have passed since recently that we want to update 8585. In a nutshell, although it is a pretty short draft, encourage everyone to read it. You need to be using unique IPv6 addresses per interface so that we can do stateless CLAT for tons of reasons. We use from the previously defined /29, which puts a maximum with that combines to make a maximum of 8 CLAT instances on the same node. We think that's feasible, but would love to hear feedback if that's not the case, as well as use of DAD. Updating 8585 is promised to include the pref64 RA, which allows us to do this without the network having to support DNS64. And right now, deferring to IPv4 native support when present, and then otherwise going through these discovery mechanisms in order when using CLAT. So a couple open questions that we're tackling as a result of this. Speaking of IPv4 versus using CLAT, currently we prefer native IPv4 always. However, we're currently conflicted as to if you discover CLAT before you discover IPv4 availability and then later find it, what do you do? Go back to it, which will temporarily disrupt connectivity, stick with CLAT, might have a performance hit. We're thinking about it and open to feedback. You can use option 108 to disable this without affecting IPv4 only hosts, but that doesn't apply to all situations. But if we say by discovery only that we're going to go to CLAT even when IPv4 is available, there are issues with networks that weren't accounting for that, and having spoofed non-DHCP channels redirecting you to CLAT may not be desirable. So, an open question. Less of an open question and more talking about how to deal with prefixes. We just saw Jen described what happens when we don't do address selection correctly, but we think that for native IPv6, that's something we're all doing pretty well. For CLAT implementers, turns out you need to make sure you're doing the same thing, because if you keep using the same CLAT source address after you get a new PIO, fun things happen. And we don't want to have fun when it comes to this. We want everything to work. So we're working through how to word this. So the 00 submitted last time. Since then, we've revved a couple of times to address some of the points that we've discussed, although those 2 questions are still being addressed. The GitHub's available. People are welcome to come comment, and we are seeking adoption if the group finds this useful. I'm seeing nods, but mic line maybe.
Okay,
cool.
We can
like that.
We can, yeah.
Oh, here we go. Now we got a queue.
Nick.
Interestingly, Janlinkova, interestingly, oh, sorry, Nick. Sorry.
I don't have anything incredibly groundbreaking to say other than thank you. This is important work. I think a lot of the CLAT progress that's happened recently over the last year or so has been instrumental in sort of forwarding on the V6 implementations and making it easier to go V6 only, which is something that I have a very vested interest in. So thank you for doing the work.
Thank you.
I also don't have anything groundbreaking to say. I think it's good to document some of these gotchas. Some of them were learned by experience. Yeah, so I think we should definitely adopt it, because this is, even though there are gotchas, this is production ready, and it is very clear production ready. And I think having an RFC that says this is how you do it is good. It'll help network operators as well. I think not just the host developers.
And Janlinkova, so that question about do you prefer CLAT or do you prefer native IPv4 when you have both? It's actually very similar to the question which I had for Happy Eyeballs draft. If you have native IPv4 and you have DNS6.4 synthesized destination, which one shall be preferred? So I think it's a kind of fundamental question for this group probably. Like, what do we really want? If you have native v4 connectivity and you have non-so-native v4 connectivity and you have faked NAT6 v6 connectivity, what the preferences are. It would be actually interesting to discuss, but I don't know. I don't have an answer which format of the discussion should have, because I think it's applicable both for this and for Happy Eyeballs draft.
And I would expect that that's going to be a depends, where we'll need to document the trade-offs rather than having a single recommendation. But it'll be interesting to see what people think.
From a sort of deployed perspective, I think Android prefers native IPv4 over CLAT, but the reason it did is that when the code was written, the CLAT performance was terrible. And so these days, there's no really good reason. That said, it's probably not, I mean, you could argue that it's actually a configuration error for this even to happen to you, right? Because if you have option 108, this won't happen, right? So if you have, option 108, so I think, yeah, maybe, and an option 108 gives you actually a clue about what the network would want you to do, I guess.
What I heard was we should do a perf bench at a future IETF hackathon against the CLAT network.
We did fix it.
Okay.
So, Janlinkova, so it's not really a configuration error, because Pref6.4 discovery and CLAT start might happen much faster than DHCP exchange in some cases, right? So it might be possible that you discover your IPv6 connectivity before DHCP and you discover IPv4 later. So the question is, what do we want to do in this case? But yeah, maybe we need to have a separate discussion in general on preferences before V6, CLAT, NAT6.4 to with-only destinations and so on outside of this.
Does it matter to the network operator what happens? Or is it something really that hosts could decide themselves based on, for example, the performance of the implementation? Can the network operator even tell what's happening?
Network operator might be interested in that case, because what I did for our V6 only pilot, I turn on DNS6.4 for everything on dual stack network to see how much V4 I still have, right? And if you want to do some measurements based on this, at least monitor your network, it would be, operator might be interested to know what the expected host behavior. Okay, maybe we do not care, I don't know. It's just something we were thinking about specifying.
If nothing else, there are some security trade-offs that should be documented, even if there's no normatives, is the thought.
I mean, these days I would support should use CLAT over V4 on the assumption that if you have it, probably that's what the operator wants. Otherwise, they wouldn't have provided it, right? Especially if you've got Pref6.4, that's a pretty strong hint that like you want people to do it.
Cool. Thank you, everyone.
Thank you, Tommy. Back to you, Jen.
Hello, it's me again. Yeah, so last IETF in V6OPS, I presented what we've done with V6O, mostly deployment. And a few people told me that it would be nice to have a draft about this. So here I am. So motivation again, yeah, I was asked to do this. And before writing a draft, I normally try to think how the word will be different if I do not write it versus I'm writing it. Is it going to change anything? Well, hopefully this one might, because I kind of assume that everyone knows everything about this V6 mostly stuff, right? It's very simple. But based on some discussions I had in the lobby, I found it might be not so obvious. And not everyone likes to watch YouTube videos instead of reading text. So in addition to my previous presentations, which were recorded, you now have a few pages of text. So documenting what we've done, how we did it, why, and what I wish I knew when I was doing this. So yeah, Nick is a new co-author, and I'm looking for other people who deployed that, because this is everything except one paragraph is basically written in my blood. I've done that, I can tell you it works, and there is a section about what didn't. So, clicker. No. Oh, yes. So I'm not going to talk about like the whole document. I'll give you a quick overview and focus on interesting things and maybe like open questions. So document structure, I'm trying to talk about what is V6 mostly network, which is kind of simple. Is the network when you can have V6 only, dual stack, and VF only devices in the same like link without creating different links for every type of devices. Interesting question, and I had this discussion yesterday in the lobby. What is V6 only capable device? I do not want to play the game of definitions here, because for every definition I could come up with, it will be a counterexample. But I think it's important to understand that generally, I would think about it as a device which supports 464 XLAT. Because if it does not, it still could be V6 only capable, but it's a policy decision. My laptop was V6 only capable without CLAT because I only use browsers and SSH. I have very special devices, embedded systems, which are currently V6 only, and I know they're V6 only capable because they sit on V6 only network and they only talk to V6 enabled servers and they don't talk to anything else. And I know they work, I tested them, I rolled them back, out. So it's a kind of policy decision for an operator to decide. If network is controlled, you might claim any device V6 only capable after you tested it. If you do not control the device, I would assume we shall expect device to understand to run 464 XLAT, CLAT, and advertise option 108. Because yeah, there are other ways of making device V6 only besides option 108. I do this for some devices which do not support it. I basically provide a radius ACL as a result of .1x authentication. Here is your ACL, which blocks all IPv4 on the switch port. You are now V6 only. Congratulations. So and draft talks in general how to provide access for VF only destinations, 464 XLAT, Pref 6.4, and interesting discussion about DNS versus DNS 6.4. Like traditionally, we kind of think about V6 only, or V6 mostly networks needs DNS 6.4 because it needs for two things, right? It needs for 464 XLAT, for CLAT to do prefix discovery using RFC 7050. But now we have Pref 6.4, which has a lot of advantages. But second use of DNS 6.4, if device does not do CLAT and it just wants to access using V6 capable applications, we need to talk to VF only destinations. It would work, but it would break DNSSEC. Also, it would break devices if you configure DNS server manually and want to ignore network provided resolvers, and this does happen a lot, especially in enterprise environments. If you want to use DOH and your browser or your laptop uses that stuff, well, Jared, you want?
I kind of wanted to jump in because there's some Android devices that seem to ignore resolve, like the provider giving out DNS.
My laptop ignores it because it's a corporate policy, so that's okay. Device can ignore the network provided resolver, device decision.
Yeah.
So that's why DNS 6.4 is kind of not working very well.
Yeah. There's some Google devices that do.
Not just Google devices. So anyway, like that's exactly the discussion this section contains, right? So Pref 6.4 is much more reliable way for a device to get CLAT enabled because it would work no matter what your DNS configuration is, right? So the only reason to have DNS 6.4 in the network is if you expect to have unmanaged devices which you don't know about, which cannot support CLAT and Pref 6.4. Lawrence, you want to comment on?
I wanted to add that you can provide a stub record. You can basically stub out IPv4 only.ARPA and otherwise provide normal DNS, and the detection will the detection. That's what I mean. Like its purpose is to be rewritten. That record's purpose is to be rewritten.
I love this.
So
we need to have this on the. Great.
There's an operator in Poland that did this because they wanted the traffic to go through the v4 NAT, not the v6 NAT. They wanted to force use of CLAT without doing DNS 6.4. So yeah, you can basically stub out IPv4 only.ARPA, return a quad A, but like otherwise do no needed DNS 6.4.
God, it's been a very useful meeting already. Thank you. So. Yeah, so then the document talks about solution benefit. Why would any sensible human being do this compared to dual stack? We all know dual stack does not solve the main problem. We still need v4 and simplifies operations. And actually it allowed us to reduce, for example, SLO on DHCP v4 servers because it's less devices using them, less devices care. So who cares about that stuff, right? Compared to v6 only, as I explained last time, it's much easier for users because you don't have 25 different SSIDs, easier for network and so on. But I don't want to spend time on this. Incremental rollout. It's actually an interesting point here. Some devices send option 108 unconditionally, right? Actually, most of them. So in this case, you can do actually per device rollout. You need to do it per DHCP pool, per subnet rollout. It's what we did. We enabled option 108 per a given subnet, first few, then 5%, 10%, and so on. And then for devices which you can control and turn it on and off, namely, it's actually Linux and Chrome OS currently. You can enable it per device and see how it works out. And as usual, it's always good to have an opt-in first for geeks. Invite them. They will come back to you screaming about all bugs they found. And they will be willing to troubleshoot them with you. So operational considerations, what you need to know when you're doing this. We've discussed it on the list. You can have DHCP v6 INA, but all implementations I'm aware of would need Slack with a bit set to generate 464 XLAT address for CLAT using Slack. So if you have strict filtering policy, please permit fragments in ESP, because fragments, yes, because DNS and radios, by the way. Internally, if you filter fragments, you'll probably will have a huge problem with .1x. And ESP, because it's VPNs and Wi-Fi calling. Well, then there is a big section about typical issues, what you can expect, what might possibly go wrong. And what is important here is that it's not about bugs. I can talk about bugs for like until next IETF. We'll all like start here. It's about things which are either design decisions or fundamentally might go wrong. It's not about like, your vendor did something wrong in the code. So let's talk about them a bit. Most common thing, actually, a number of complaints I've got, it's that for years and years, your tech support might be telling users, something does not work, disable v6, or problem fixed, ticket closed. So you might have a lot of corporate devices or unmanaged devices which v6 disabled or maybe misfunctional, not working because of firewall or something. This is a problem. So obviously for managed networks like corporate network, we basically had to enforce automation to go and re-enable IPv6 on all those laptops and so on. For unmanaged devices, at least if you do it for the first time, like conference network, you might want to have a fallback SSID, but it probably needs to be hidden. You want to prevent users from connecting to it accidentally and only use it for known problems, because otherwise people will connect to it even if they don't need to. Well, network extensions and multiple addresses per device. This group probably well aware of those two problems. We've been talking about them for like last 12 months approximately. We have proposed solution for this, which is currently with ISG. Fragmentation, interesting case. So you can have 1500 MTU on both sides, but because IPv6 packet happened to be 20 bytes longer than IPv4 all the time, if you get 1500 IPv4 packet from internet, it will still be fragmented, unfortunately. And surprisingly, actually it's per RFC, default value for fragmentation is 1280. So you're actually fragmenting everything which is bigger than 1260 IPv4 traffic. Fortunately, firewalls do allow you to configure that, at least some of them. So if you deploy this, it would be, I recommend checking your configuration. And if you know that your internal IPv6 network supports reasonable MTU, make sure they don't fragment on 1280 and they fragment on 1500. So it will drastically reduce amount of fragmented traffic in the network. Custom DNS configurations, yes, back to this topic. Users do have custom DNS configuration on devices, right? It might be corporate policy, might be manual config. As soon as this happens, your DNS 6.4 configuration stops working. And the symptoms are interesting, right? The symptoms are, I cannot reach some sites on the internet, right? It's not like nothing works. For us, I found that some users have been suffering that for a while before they even complain, because internally everything works, right? So again, Pref 6.4 should be enabled in array. Interesting problem, actually. Yeah, probably it should go to CLAT draft, I don't know. So if you do traceroute 8888 from your CLAT-enabled laptop, it's obvious how to represent and traceroute everything after NAT 6.4, how to represent V4 infrastructure. What to do with V6 addresses? You see nothing there. Operations team is very unhappy about this. Users are unhappy because they're confused, like, I do traceroute, you have packet loss, everything is dropped. So I don't have a good solution for this. I'd like to hear the room opinion. I don't know if it shall be in CLAT draft or it should be something different, but I think it would be nice to have a universal solution, because some implementations are creative. They use reserved V4 address space for this just to show at least something. But let's think about what to do here. And actually, that's it. So again, I would love this draft to be adopted, and indeed, I would love to hear comments, suggestions, other like war stories, experience, whatever is missing here.
So Warren Kamari, this is only partially related to the document. I know a bunch of people here don't go to the plenary, but just a quick heads up, I'm going to be announcing in the plenary that we want to move the IETF SSID to be IPv6 mostly. Some set of people will freak out, and so we'll still have like IETF-public v4 or something like that. But anyway, we're going to be asking for feedback because, you know, we want this network to work for the users.
And so show up in the plenary to support Warren.
Given the variety of ways that we have to hand out DNS servers in V6, you know, because you can get them in through DHCP v4, you can get them through
V4.
Yes. You get them through RAs, or you could get them from either you know, through DHCP v6 as well. Is there a recommendation for operators of which ones we shouldn't be doing?
I didn't even think about giving V6 servers in IPv4 in DHCP v4, because why?
It
well,
yeah,
well,
yes,
well,
it happens all the
I
time.
didn't ask how. I asked why. So
Yeah,
anyway,
you
like,
can do it.
okay, so as long as they're consistent, I do not see like I don't use DHCP-V6. You know, for me it's only one Slack. So
what with VI? I mean, like, I mean, DHCP-V4 only has a 4-byte field. Lorenzo Filidi, please adopt 2 years ago. I think this will be that, like, I really think this is going to be the most useful document that we have produced in a long time in this group. I know I'm biased, but, you know, I am not, you know, I don't think I'm involved. I don't think I'm an author in this one, but I also would say that while I do like the term IPv6 mostly, I think it's not ambitious enough. I think we need to say that this is the way, because I have not seen any other way to transition to V6 only. In any other, I have seen no other way, not only like not even work, because it does work and we know that it works. I haven't even seen it written down. So I think we should rename this to, this is how you transition. Transitioning and networks from V4 only to V6 only. Because, you know, I don't see, I mean, if anyone else has any other way that they think is going to work, yeah, we can talk about it. But otherwise, I think this is the only way.
Thank you. Naming discussion can consume like the rest of the session. I think the goal was to differentiate between V6 only when you do not have V4 to V6 mostly. Yeah, but we can talk about naming.
Implementation details. Yeah, I mean, I think we just need to show, because it is a fairly it's put together from multiple pieces and they just all work well together. So I think there's no need to call it anything. It's just this is how you do it.
Stuart Cheshire from Apple. A really quick point, not disagreeing with anything you said, but just in terms of accuracy when you're updating the document. You talked about the very real problem that if a user or a corporate policy is ignoring the DNS result learned from the network and using Quad 8 or something else, then IPv4 only.ARPA doesn't work. And that is exactly right in 7050, which is why we had to write 8880 that said, even if you're not using the result you learn from the network for your DNS queries, IPv4 only.ARPA is actually not a DNS query, it's a middle box communication protocol, so you need an exception for that. So that has been discussed. So I don't want you to be making arguments that are easy for people to pick holes in. Doesn't change that anything you said, it's still a good idea, but just in terms of accuracy, you mentioned that.
Okay, thank you. I'll talk to you later about this because, yeah, I didn't know, and it's not what I'm observing. So obviously, yeah, there is something not doing the right thing here.
Okay, thank you, Jane. Jeff.
Thank you. Hi, Jeff Houston. This is actually a working group in the operations area, and this is a talk about operations, oddly enough. It's not really a talk that had a draft, although there are some drafts and some RFCs before it that actually motivate why this particular set of observations is important. 20 years ago now, we published RFC 3901, V6 Transport Operational Guidelines. And if you read it, it's actually kind of bizarre, because what it says is, if you want to make this work for DNS, you need V4. You know, if I paraphrase the recommendations there, every recursive name server should be either V4 only or dual stack. You need V4. Every zone should be at least one V4 reachable. You need V4. So despite the title, it really was better not ditch V4. That's what it said. There was one that was actually talked about in this very meeting back in Prague, 3901 BIS, that said almost the opposite. Almost the opposite. There's no mention of V4. And it says, well, you should have at least one V6 reachable and recommended to, and there's no recommendation around anything else. What it's really saying is take V6 seriously, and it's not saying keep V4 going. It's kind of saying the opposite. Better kind of move on. And I suppose the assumption behind that particular draft, the assumption was 20 years later, it's kind of time to think about running infrastructure, and the DNS is about the most important infrastructure in the internet. It's about time to think about doing this on V6 because it is as efficient and as fast as V4. Really? Now, I hear a lot about folk making claims about V6. I've lived through it for 3 decades. Most of them, oddly enough, are bullshit. Very few of them are actually done with massive amounts of measurement on a network. So it seemed time to actually put this to the test. How much of V6 is supported in the DNS today? Not tomorrow, today. And quite frankly, how does it perform? So I've actually brought this down into 3 questions. Most of the V6 out there is in a dual stack context. So how does the DNS actually work today in dual stack? Is there a happy eyeballs? Do we see evidence of this prefer 6 and then try 4 if it doesn't work? Or oddly enough, is there the reverse of V6 first, a preference to actually use V4 even in dual stack? The second question, if you're brave enough to stand up V6 only, will it work? Will the same set of folk be able to resolve your names as they would on dual stack? And the third question, which I learned a new term in the Deleg BOF, I think it was yesterday. I am a DNSSEC snob. Okay, let's just bring that out there. I think, you know, trusting that if you send a packet to the right address, you get a trustable answer is indeed crap. That is not the way it works in today's internet. If you really want to believe the answer you get when you send a packet off into the wild blue yonder, you better have a look at the crypto, because otherwise you have no idea what comes back. So DNSSEC is important. So how well does V6 work with large UDP packets and DNSSEC? Because that's kind of one sentence. So we did this test, Joao and I, back in December and January, using around 500 million individual measurements, a relatively large cross-section of the entire internet. And thank you very much for Google for their ongoing support in doing this. I do this through ads. Everyone gets ads. And ads, oddly enough, are quite amazing, because inside an ad is scripting language. And all the scripting language does for me is to get URLs. Great. I use unique domain names to defeat caching, and then a customized DNS server and a customized web server. And in this case, I'm really looking at the DNS and looking at how many folk come at me. Now, the funny thing about the DNS is that you might think you might ask one query. You would be wrong. When you ask one query from your browser, somebody immediately turns it into 2. Around 46% of all end users, a single query in this scripted ad becomes at least 2 queries, and it's the DNS infrastructure, or 3, or 4, or 5, or 6. And some of you, anyone want to put their hand up, are astonishingly enthusiastic and can offer 10,000 queries with exactly the same query name inside around 5 seconds. You're not putting your hand up, but we know who you are. Amazing. Now, my machines always answer, always, as fast as they can. No tricks. It obeys what's in the packet. So if you come at me at TCP, it's TCP. If you offer some kind of, EDNS 0 buffer size parameter, it'll obey that. V4 only. So I'm dual stack, and of the 1, 2, 3, whatever queries I see, if all of them are in V4, 43% of the queries that were asked, 43% of users on the internet by inference are V4 only against my dual stacked authoritative server. The resolution system in the DNS has a 43%. Well, it only seems to ask V4 questions. Interestingly, 11% of users asked only in V6, in the 1, 2, 3, 4, in whatever queries, right? It asked only in V6. It liked what it got and moved on. And 46% said, I'm going to ask you twice because you might give me a different answer. I don't know, whatever. 46% asked me of users were behind resolvers that asked in both protocols. So quite frankly, less than half of all these name resolution query sequences show both protocols. It's odd, there's only one server. It does have 2 addresses, but the query farming doesn't seem to sort of change the protocol very often. You just change the resolver and hope you get a better answer, I guess. Is there happy eyeballs? Mark Andrews has had to, I think, leave to go back to Sydney. Of the folk who asked twice, twice or more, I look at the first 2 queries, the first 2. And if there was a preference to use 6, I would expect the first query I see to come at me in 6. The second query to go, well, it's one name server, you've got 4, I haven't got the answer in time, I'll ask again in 4. Now that only happened around 22% of the time. The exact reverse, around 20%, V6 only around 20%, and V4 only, as you see up there, around just under 40%. I don't see a bias to 6 in that data. It may be there, and indeed the folk behind bind tended to suggest that they have code that when they order the name servers, they will prefer 6, but the experience here does not seem to bear that out. Hi, Stuart.
Do you want questions now? Or
Oh, yeah, fine.
I'm Stuart Cheshire from Apple. I just want to make sure I'm understanding what you're showing here. It sounds like for the green bar, a recursive resolver somewhere sends you a V6 query, which you're answering as fast as you can. But regardless, the recursive resolver goes too slow, I'm going to give you the same query again.
Another resolver. It may or may not be the same one. You see, in the DNS, we actually don't know what a resolver is. And sometimes it's a farm, sometimes the query is forked. You know, I get questions for the same query name. Each ad, each measurement is a unique name. So folk are asking me the same name. Now, it might be the same IP address asked me in 6 and 4. How do I know it's the same resolver? Really good question. I'm not sure. So I can't say it's the same resolver flipping protocol stacks. I'm saying that if the first query was 6 and the second query was 4, it would be strong evidence that there's a V6 bias out there. And that's great, but I can't see it in that data.
Okay, so maybe I'm missing something obvious here. Why is there a second query at all for the same name?
Whoa, there are PhDs going. There's all kinds of folk who would love to answer. Why is the DNS its own piece of AI? I think it's a sentient life form, Stuart. We just haven't recognized it for decades. Yeah, why?
Okay, thanks.
Great question. I'm busy pressing next. I really am. I'm pressing next. What happens now? Do I press back, forward? You were moving your mouse. Yeah. Okay. This is one of the more puzzling parts of the DNS because I look at those first 2 queries and I analyze the time difference between them. You will see peaks. This is in milliseconds at 370, 400, 801 second. Those are real timeouts because that's code that we know and understand. OpenDNS, Bind, Microsoft resolvers, etc., that have timers. Way out on the left is this crazy stuff where folk just ask multiple queries back to back. There is a theory out there that I frankly think is really good, that the most demented piece of software in the DNS is free. It's DNS mask, and it sits inside CPEs, and DNS mask just simply thinks, well, because queries are free, I'll make a lot of them, a huge amount. And this back-to-backing that occurs up in the first 20 milliseconds might well be the reason why all this other data gets clouded, because right at the edge, there is insanity, absolute insanity, because who can resist free software? Evidently none of the CPE vendors. Pity, really. So the answer is there's no, in what we see, there's no pronounced happy eyeballs version. You might say, well, DNS mask sort of covers it over, but what we see at the authoritative is there's no V6 preference to answer, you know, so no, there's no happy eyeballs. And there's a slight bias in V4. If we go back to that data, 40% of queries, multiple queries are in just v4 only. Okay. So the answer to the first, no, and probably. Second one, I'm going to put it in v6 only. Do you want me to pause, Stuart? Oh, okay. I'm going to put it in v6 only. How many can reach me if the only way to reach me is in v6 and I'm counting users, I'm not counting resolvers. So it's a really simple thing. 35% of users sit behind DNS resolution infrastructure that has no v6. 1/3 of the world has no v6, which is actually better than users. The same test in the web says 35% or so have v6 capability, the rest of the world doesn't. In the DNS, it's up to 65%, but it's still not that good. And it's not, you know, the DNS infrastructure is not that big, but it hasn't really moved. Interestingly, when I dual stack, 43% go, look, I'm sticking to 4. As soon as I say it's v6 or nothing, 10% of those folks sort of get flushed out of the woodwork and say, okay, I was lying. I really can do 6, but it's a well-kept secret. Maybe it's sort of the 8th choice or the 10th choice where they keep on pounding away. Will anyone do 6? So slightly, there's 10% that are hiding it. So 65% of users will see you if you're behind v6 only resolution infrastructure. And now the big one, because quite frankly, you can either put your trust in the web PKI and certificates, or you can actually understand that A, this is not an address-based internet, it's a name-based internet, and B, the only means of authenticity and trusting your answer in DNS is, oddly enough, DNSSEC. It is important. It is really important. But I'm a DNSSEC snob, so what the hell. In DNSSEC, you have to carry signatures around. They tend to get big. And sometimes they get really big. I looked at the root zone and simply asked it, tell me, every entry in the root zone, tell me your DNS key value. These are the size of the answers I get. Slovenia currently wins at 3,319 octets. Here's a few DNS keys. They're big, yay. What actually happens is that more than 300 sites just in the root zone, if you're running DNSSEC, you're going to have to ask for their DNS key. You're going to have to cope with packets that are larger than 1,500 octets, no matter what. Somehow that data has to get back to you if you're going to validate their answers. They're not doing anything wrong. Keys can be big. If you roll them, etc., you will get large answers. So can we measure this? Because the one thing V6 did that's caused a lot of heartache is indeed change the way fragmentation is handled. We moved the fragmentation control fields out of the header into an extension header. We changed fragmentation on the fly to no, and we actually pushed control signaling that has a consequence from the middle of the network back to the source. Unauthenticated suggestions of no particular way of actually authenticating them. And then when you're in UDP, you can't resend. You can't alter the packet that you sent. It's gone. So you now have to go through a large amount of effort, as anyone's tried this, that when you get back one of these messages saying too big, you've got to cache it in the forwarding table. You've then got to say for any packets to that destination, typically for 15 minutes, fragment at source. So it's a lot of work. It's a lot of work. And quite frankly, in the DNS, you might be placing too much work on the DNS timers, because when you ask for a name to get resolved, you're not going to hang around, have a cup of tea, have another cup of tea, sit around for a while. Oh, does the DNS come back? Yay, let's move on. It doesn't work like that. So in this case, what we do is send large answers. They're big. They're more than 1,500 octets. And we obey the user. If they say in EDNS 0, send me back 4,096 octets or less, send me a big answer, I can cope, we believe them. We shouldn't, because of the folk who say, I can do V6. When we believe them, 18 million of those 32 million never got the answer. 56% of users sit behind resolution systems in V6 that say, give me big answers, and when we try, it goes no. Just doesn't, which is awesomely bad. You can't run a service with that kind of down rate. You just can't. Even in dual stack, Once you go to V6 and you get that kind of problem, there's a fair dealing of effort, i.e. time, to recover. To actually go back to V4, blah, blah, blah. You need timeouts going on, and that just says, make a cup of tea, wait for an eon before you get the name. So that's not working very well. So the answer is badly. What can we do about it? We can fix the network. Yay. 30 years later, ain't going to happen. It's just not fixable. This kind of problem has now got to the stage where the install base is not going to change. We've got to live with it. Fine. So what we probably need to do is to avoid packet fragmentation completely. But I'm not telling you anything that wasn't already said in RFC Mumble back in March 2017, because in the UDP usage guidelines, it said, for God's sake, don't fragment. Do anything you want, but for Christ's sake, don't fragment. So how do we do this? Well, we change that suggested buffer size. Here, I can handle anything up to, well, I don't know, 1280 octets. And after that, truncate and don't try it anymore. Do not fragment. So we have workarounds by changing that EDNS 0 buffer size. But do we do it? Do we do it? I haven't got the slide here. Around about 67% of resolvers are still offering buffer sizes that lie when they say, I can handle big packets in V6. The EDNS buffer size that's actually being presented, massive numbers are still at 4096 and other numbers are still ridiculously high. So somehow that message from back from 2020 that says, if you want this to work, don't try big packets over V6 for the DNS. Just don't. It won't work. Is not being heard. So
Jeff, just a quick interruption.
Last slide.
I need to, last slide, perfect.
That's it. It's not ready today. We can fix it, but this is it. We haven't got it working today. Don't try this at home today because it won't work. That was the last slide.
Thank you. I need to leave.
Bye.
Yeah, but stay for the conversation in the queue, right?
Oh, I stay.
Yeah.
Oh, I stay. Okay. Only Eric leaves. The rest of us are stuck here. Sorry, I did take 5 minutes longer than I thought. Yes.
David Lamparter. I have a reasonable belief that your DNS mask theory doesn't work because DNS mask is generally configured to forward to other recursive resolvers. So you should never see that hitting your DNS server. I think there's something else going on there and that bears further investigation.
The DNS is a wonderful thing. So many people spend so much time at it because none of us understand it. Thank you.
Stuart Cheshire. Thanks, Jeff, as always. Great work. My very quick comment is, and I might have misunderstood you, but the way you used the term happy eyeballs, it seemed like what you meant by that was a preference for V6. And that is not the intention of happy eyeballs. The essence of happy eyeballs is you rank the candidates in order of your preference, whatever that may be, and then you try the first one, and you don't try all of them simultaneously. That would be a misunderstanding of happy eyeballs. The idea is you try the first one, but then you wait for a reasonable round trip time where you'd expect to have 90+% success rate. And if you don't, then you rapidly start going through the rest. So it's not do them all at once, which is a huge waste of capacity and load on the servers. And it's not the old sequential way of like do one and be sure that it's really timed out before you try the second one. It's a middle ground. So
I remember your presentation in Seoul. Maybe you might too, a long, long time ago.
Actually, Dublin.
Oh, the race to the SYNAC, where you actually did the DNS and the opening TCP and whichever completed first, because you're trying to effectively experiment as to which protocol performed fastest. The shorthand that the industry has done is to actually do this in the DNS, and you give V4 a 50 millisecond penalty. Issue both. So oddly enough now, the DNS is the protocol switch for the web. And so actually understanding how the DNS is working in dual stack gets really interesting. Is V6 slower for the user? Now, that's a great question. And it's actually all about the density of V6 and the caching population in the V6 protocol as to where this stuff gets fed. And so the answer is, as always in the DNS, it depends. I'm using happy eyeballs as shorthand for we should really prefer V6 if we want V4 to die automatically. which
So
is a
that-
longer thing to say.
That is certainly within the Happy Eyeballs framework.
Yes,
that
but there's more
kind
in
of-
Happy
We kind of
Eyeballs.
put our finger on the scale, and like if V4 and V6 are similar within 50 milliseconds, then we'll go with V6 because we want to nudge things in that
Yeah.
direction.
Sorry, my sloppy slideware. Sorry.
Hey, so Tobias Siewicz, Max Planck Institute for Informatics, and I was wondering whether you actually looked into like the end-to-end behavior. So at the moment, it looked more like you looked at DNS, but not at what impact that had on the user being able to request the site they were going
One of the things about ads is that you can put ads everywhere. One of the bad things about ads is I can only run a certain amount of HTML5 that's packaged in the ad. I have no control and instrumentation at the user. All of this is instrumented on the server side. So I have to infer behaviors from the other side of the connection. You can infer a lot, and there's a lot more work that I've done around RTTs, reliability, etc. But this work was just about the DNS.
And I'm arguing that that is insufficient because we need to know whether the users are able to get the resource they're trying to get via HTTP.
There's much more behind this, but this talk was just about the DNS. Do we exhaust the queue?
Hi, Bob Hinden, and good talk. Thank you. Well, two things. Just looking back, when we decided what IPv6 was going to look like, I think we were trying to discourage the use of fragmentation. That's why it was not in the main header, right?
You and I were there. I'm not sure we're in exactly the same room, but I remember Jeff Mogul's paper. I remember the discussions. We were trying to discourage fragmentation.
So it's sort of unfortunate that there still seems to be things like the DNS over UDP that still want to use it. So
Subsequent to that discussion was DNS extension, where they decided fragmentation was fantastic. And instead of the old conservative 512 octet, they come up with, well, let's put a field that goes big. What's a good number? You read the early drafts of that eDNS 0 thing, and it says, oh, 4096 will work. So somehow there was a bit of amnesia between the V6 developers, who at the time had read Jeff Mogul's paper going, this is bad, and the subsequent bullish view of the DNS extension folk that said, this just works.
Right. So my last thing is sort of, you didn't talk about running DNS over TCP or other transport.
There's a
protocols.
bunch of other talks about truncation and TCP. The good news for V6 is, with the exception of some sloppy filter rules, are you listening, Telstra? In your network, V6 and TCP and the DNS work very well almost everywhere, except some networks in China who aren't listening, and Telstra's network in Australia, where I know it does it. But the filter rules say 33% of users behind Telstra don't get the answer if the answer is TCP over V6 for the DNS. So it works, Bob, it works, except for Telstra. Filter rules.
Lorenzo Colletti. So my personal opinion is that if you use fragmentation, you have waived your right to any sort of correct behavior, right? That's my and I see people on my team going through bending over backwards to get fragments to work and like do BPF acceleration for fragments. Why do we bother, right? It doesn't work. I don't see any path to getting 56% to 100%. I think we should just deprecate it and call it done. It failed. We can't do fragmentation. End of story. If you want to send big packets, you need to provide your own layer. Sorry.
No, when you are a server and you are answering queries, sorry, it's a mic thing. Let me quickly respond. When you are a server in the DNS and you're answering queries, it is a gigantic leap of faith to go, no, I'm not going to answer you. It is a big leap of faith. You try. And what's going on is, with fragmentation, if the user says, I can do this, one knee-jerk reaction is to go, you said you could, I will obey you. And the answer gets lost. And then all kinds of timeouts, retransmit, try again, have another cup of tea, just takes its place. I can't blame these folk for writing code that persists in trying to get an answer through when, as you say, truncate the lot, don't fragment, move on. The RFCs say, don't fragment over UDP. You know, there's this background, even Flag Day, that said, cut it down, don't try to do it. But for some reason, the industry out there and all this deployed mass of what we think are resolvers are going, oh, I can do it. You know, you can't, but I can do it. So this is not an intractable problem. It's easily fixable if folks stop trying to send large answers over UDP. It's end of rant.
So Warren Kamari,
Yep.
I got a bunch of dirty looks when I suggested we should like take a step back and have a hard look at the protocol and the architecture. But exactly things like this, like maybe we should have a look and decide like fragmentation really was a mistake. And maybe we should just say you can't do it in V6 or similar things. Like it feels like we've been trying to operate this protocol for long enough now that we've learned some things, but it doesn't actually feel like we're willing to take those learnings back into.
There's a draft from Jen Linkova and the one that said fragmentation drop rates are amazingly high. RFC something or other. Yeah. Fernando gone. Yes, but one of the responses was a draft by Ron Bonica that actually said, let's deprecate fragmentation in V6. Just ignore it. Think that there is no such header and move on with your life.
Yeah, that kind of was my suggestion here too, just to clarify what I meant. Yeah, let's just give up on the
Right.
fragmentation
Interestingly,
header.
that draft got nowhere, but I think in practice, the industry wasn't listening and it really should have gone somewhere because it doesn't work very well and it just creates a nightmare. And on that happy note, let's all go and have lunch.
Thank you, Jeff. Thank you, everybody.